Do it. I got faith in you. Come on, computer. Well, it didn't make the noise. Oh, because I'm muted. That's why. All right. So, you said it was due February 7th of this month. Okay, Declan, hold on. I did this in Earth Space too because, hold on, let me fix it. Apparently the opener is saying, oh, wrong day. Yeah, it's just the wrong one. I just got to adjust the date. I did the exact same thing in Earth Space. All right, edits. Hold on, let me fix it. So March 3rd, March 2nd, March 4th. Okay, I'm fixing it right now, Declan. If you refresh your screen, you'll be able to put in your answer. All right, so y'all, shh. Yesterday, we learned how to do a different thing with stoichiometry. Up until this point, the mole has always gotten a 1, always. But that is changing with what we learned yesterday. With yesterday, if you're switching between moles of different substances, they come from a balanced equation. And it's been a little while since we have balanced equations. This is actually how to balance the first one on the workday thing that we're about to do. I'm not going to take up a lot of your time. Who did not pick up this paper and needs a paper copy? Because this opener is how to balance the first equation. This is the oxidation of iron to make what we commonly call rust. Iron 3 oxide. Let's see, take the version of this. Okay. I don't know if I'm going to go through all of the balancing with y'all or not, but it's crucial that you have the right coefficients to be able to do the mole conversions. The mole conversions themselves are really simple as long as they give you a balanced equation. That's what makes today the workday, is you need to make sure you can balance equations. So with this opener, I unfroze my screen. With this opener, how many irons, which is Fe, how many irons are on the left? 1. And how many are on the right? 2. If you've not noticed, I always put my drop-down line right underneath the arrow, which is like an equal sign. On the left, how many oxygens do we have? 2. And how many are on the right? 3. So I have 2 problems here. Now, I understand that oxygen, with the exception of a combustion, you start with oxygen, which I've mentioned before when you're doing balanced equations. With a combustion, you actually end with oxygen. But in this case, we're going to start with it. If I have 2 on the left and 3 on the right, what is the common number going up that they both share? 6. No, going up is a 6. More often than not, if you just multiply 2 values together, that's going to give you the most common. Denominator is not the right word I'm looking for, but going up in value. And so on the right, I'm going to do 3 times 2, and on the left, I'm going to do 2 times 3. It is not the total value, it is the multiplication number that needs to go up into the whole. And on the right, this times 2 is going to go in front of rust. I know they can't see me pointing on the screen with my finger. The thing that you're going to forget to do that's going to mess you up is to distribute. So I don't just have 2 times 3 oxygens. I have 2 times 2 irons, which is a total of 4. And so originally, my iron was messed up, but now, Sharon, Stop.
I'm listening.
No, you're not. You got flashing lights going on in your face. You are not listening.
It's 2 plus 3 equals 4.
2 plus 3 equals 4. It does, doesn't it now? Lies. Put it away. So on the right now I have 4. On the left I have 1. Now originally you would have, if you would have started with iron, you would have done ×2. That just wasn't enough. Like I said, I know that oxygen is the problem child and you normally start with that one. So to make these both the same number, if I have 4 on the right now total, and I have 1 on the left, what are you going to do to the left-hand side to make it equal? Times what? Times 3. 4. Times 4. This 4 doesn't change anything else. Every time we put in a coefficient, we distribute if we can. We don't have to here. And then we just double check. With iron, 4 is equal to 4 on both sides. How do I fix the oxygen now? Times 3. Oh, that should be a 3, not a 1. This is a typo. Fix it right now. This needs to be times 3. I swear I double checked this. And I still made a boo-boo. Times 3 equals 6. There we go. Now it's right. Go back up here. Okay, so this is the correctly balanced equation for the very first formula that's on the worksheet. I need to go back. That MOLAB thing from Friday is a test grade. I haven't even had a chance to check online to see who turned it in digitally. What I did have turned in via paper. Had one from Tatiana, who's not here right now. And that looks like that is the only paper version I had turned in. That was the one where you were supposed to figure out who was the bomber, who was the murderer, and who was the person who was murdered. Actually, I had some that I did have turned in because y'all's group did it right the first time. I had one turned in from George, Bailey, Sahara, Caitlin, Logan, Jared, Valerie, Jimmy. That I actually physically hand graded as of last week. Either you turned it in digitally, or Tatiana was one that turned it in that I've not graded. That was a physical hand copy. I will still take them. I need to go back into Canvas and give it a day extension for those of you that were remote to make sure you have the opportunity to be able to turn it in. So really, with today, and I know there's another slide. I know there is. How many moles of rust can be produced? I'm actually going to go ahead and answer the whole first question with you on today's assignment. So we balanced it, even though I had a typo on my thing. How many moles of rust can be produced if you have 2.9 moles of iron and plenty of oxygen gas? If it says that something is in excess, or something you have plenty of, or you have more than enough of, that's not part of the problem. That's what's called an excess reagent. We're concerned with the one that controls the reaction, which is the one that's going to run out first, which is called a limiting reagent, which will eventually be Friday's lesson. What are you actually starting with on this problem? 2.9 moles of iron. And so whatever my answer is when I smash buttons in a calculator, I'm going to want to round to 2 sig figs. I don't want to be in moles of iron, so I'm going to drop those. What are you trying to change it into? What is it asking you to switch it to? Moles of rust, which is the iron 3 oxide. That's the chemical formula for rust. That's what that is. These numbers come from the balanced equation, which is, even though I had a boo-boo on the previous slide, they come from here. And so we're dealing with rust and we're dealing with iron. Iron gets a 4 and the rust gets a 2. I just couldn't fit everything on one slide. Moles of iron cancel out. Now, I was always personally taught to reduce. You don't have to. Really, it should be 1/2 instead of 2/4. If you want to simplify or reduce, you're more than welcome to. Okay, but the calculator will still do everything if you put it into the calculator correctly. I would do 2.9 times 2 divided by 4, which still have to check myself and make sure I didn't make another mistake. 2.9 times 2 divided by 4. And when I round to 2 sig figs, 1.45 rounds up to 1.5 moles of the iron trioxide or the rust. This is all we are doing today. What you need to make sure that you do right first is that you balance the equation correctly, because these numbers that go, and I can't see me pointing on the screen, these numbers that go in front of the mole, they're going to be dependent on what the balanced equation tells you. The mole does not always get a 1 anymore. The mole gets a 1 if you go in between moles and grams of the same substance, moles and representative particles of the same substance, or the one that we've not done between moles and liters of the same substance. But if you're going between moles of different compounds, these are the coefficients that are in front of the compound from the balanced equation. And if you don't have it balanced right, I don't care how well you set it up, it's wrong. Okay. This is literally all we are doing. There are no notes today. Today is a work day. If you did not finish off that mole lab, which is a test grade, the mole train is a test grade. I'm about to open that back up in Canvas for those of you that are remote. Give it an extra day. Hold on here. Let me go back to Friday. Yes, no, you're not leaving. No, you need to stay in here and I need to help you because the person in there is not a chemistry teacher. I am. I am the chemistry teacher. Let's see here. Let me give you an extra day for those of you that are remote. As far as that mole lab, is there anybody that had that to be turned? Oh gosh, my computer sounds like it's about to take off into space. There, it stopped. Yes. Yesterday's notes and assignment. Yeah, hold on here just a second. And really, all we did yesterday was this easy one-step using balance. Okay, so before y'all start working the problems, you're going to want to ensure that you do have a properly balanced equation, because like I said, if these values are not right from the balanced formula, I mean, you can set it up perfectly, but you're not going to be able to calculate it the right way because you have the wrong coefficient. Let me stop the recording.